Hi everyone, welcome to Vishwablooms. So in this video we'll be looking at class 10 science NCERT first chapter chemical reactions and equations. Let's begin. So before starting this chapter we need to understand few things, that is the prerequisite knowledge. So there are two things which you have to understand before, then which will make understanding this chapter easier. So first is the physical change and second is the chemical change. It's not a problem if you don't know also, now we will understand. So first we'll see what is physical change. So physical change is a change where no new substance is formed, and mostly these changes are reversible and they are temporary changes, they are not permanent. And most importantly, there will be no change in the chemical composition. This is very important. Okay, we'll understand with chemical change and the difference. Okay, so generally in physical change, all the change in states we consider it to be the physical change only. Suppose you have an example here. So melting of ice. See, ice, see, when it is getting melted it becomes water, we all know this. So here it is just the change in state, it is getting converted from solid state to liquid state, so it is going to be a physical change. So all the change in state, that is going to be a physical change. Okay, this is what is something you need to know, and that would be enough for physical change. But we need to understand chemical change very more clearly. Okay, so let's understand the chemical change. So here we have a definition here. A change of material into another new material with different properties and one or more new substances are formed. See, in a chemical change generally new substances are formed, that is very important. Okay, whereas in physical change there are no new substances going to be formed, right? Here we will surely have a change in chemical composition. So chemical composition will surely change, some or the other change will be there. Whereas in the physical change we cannot see any chemical compositional change. Suppose if you take the same example, even if it is in the form of ice, the chemical formula is H2O. Even if it is in the form of water, the chemical formula is H2O only, there is going to be no change in chemical composition. Whereas in chemical change there is going to be some or the other change in the chemical composition, and these changes are mostly irreversible. Okay, mostly, some can be reversed but mostly they are irreversible, that is why I have mentioned mostly. So I hope physical change and chemical change is clear to you, so that we can move on to the topic actually. Okay, so first lesson for today, let's see. So I have told that the topic, the title what is given to this chapter is chemical reactions and equations. So first we will try to understand the meaning or the definition of the title, then we'll move on to the topics which we have to discuss in this title. Okay, so first we will see what are chemical reactions. So chemical reaction is nothing but, in simple words if you ask me, if a chemical change occurs or it takes place, we can simply say a chemical reaction has taken place. But here we have a definition which looks very nice, right? The process in which a substance undergo a chemical change to produce new substance with entire new properties is called a chemical reaction. So chemical change is there, no? That is very important. That is why we have learned the chemical change, right? Just okay. So here what we're going to understand is chemical reaction is nothing but whenever a chemical change is taken place in order to get some new substances with entire new properties, then we can say that chemical reaction has taken place. I hope it is clear. Now let us see few examples of chemical reactions. Okay, so we have first example 1. So here I am taking a magnesium ribbon. So here magnesium ribbon is being burnt, it burns with a dazzling white flame and changes into white powder. Okay, so if you're doing this experiment in the laboratory, you will be able to understand. So generally, whenever you're going to burn the magnesium ribbon, what they'll generally do is they'll rub the ribbon with sandpaper, because the layer of oxidation, they're going to remove that layer of oxygen, so that what happens, the process of burning will take place even quicker actually. So for that purposes they will rub it with sandpaper. Okay, so this question can also come in the examination point of view, 2 marks. Okay, but you should be able to remember this. I hope it is clear. So it will burn with a dazzling white flame and will change into a white powder. See, generally magnesium ribbon is not going to be in white color. Okay, but you can see there is a change in color actually. So after the reaction has taken place, we can see color has changed into white. And not only that, there is something else which has changed, the state. It was in the form of a ribbon, with now it has changed to ash, right? So we can say the state and the color both are changed in this particular chemical reaction, right? Now we will see another example, which is example number 2. So here we have just going to take one beaker. In this beaker, first you will just add zinc granules here. Assume this to be zinc granules. Here you just add either HCl or H2SO4, either hydrochloric acid or sulfuric acid. What do you observe is, you observe a change in temperature. When you touch it, no, you will feel some hotness behind it. Okay, so here we are able to see temperature change, and also there will be evolution of gas. So gas will be evolved actually. Hydrogen gas will be evolved in this particular reaction. Okay, so whenever you are doing this reaction in the laboratory, you will be able to understand and you will be able to figure it out. But how do we figure it out that hydrogen has evolved? How we will get to know? So there is one test to get to know whether hydrogen is liberated or not. So actually what they will do is, they will close the container neatly and there will be only one pipe passing through it. So through this pipe the gas liberated will be coming out. Okay, so through that gas, what you will do is, you will put that in the soap water solution, because you have to block the hydrogen. So it will, in the soap water solution, if they put that, no, there will be bubbles. In that bubbles it will get stuck hydrogen, and whenever you are putting a candle flame near it, it will it will give a pop sound. It will burst with a pop sound. So that pop sound will indicate that there is a presence of hydrogen. So these experiments also will be there. You will be able to understand when you do it in the laboratory. Okay, so we are also able to say that gas is evolved and there is a temperature change. So when a chemical reaction has taken place, we are able to see total 4 things. Here we are able to see color has changed and state has changed, and in second example we are able to see that gas has evolved and temperature has changed. Oh, now we are able to figure out how we are able to determine a chemical reaction has taken place. So these are some factors which help us indicate or determine whether a chemical reaction has taken place or not. So I have just given examples in order to make you understand these 4 things. So let's move on to the next part of the chapter, that is chemical equations. The title second part we are going to see. Now we are clear with what is chemical reaction, we should understand what is chemical equation. So if you ask me the simplest definition for this, it would be the short description of a chemical reaction. That's it. This is the simple definition of a chemical equation. See, nothing. When you give a shortest description of the reaction happening, it is going to be a chemical equation. So here we have a definition in better words. The symbolic representation of a chemical reaction in the form of symbols and formulae is a chemical equation. But if you write until here, this is not going to be enough. You're going to explain few more things. See, generally what is explained here is in the symbolic form, by using the symbols, chemical formulas, the formulas of the compounds. By using that, if you represent a chemical reaction, it is going to be a chemical equation. But that is not enough for the definition. See, you have to tell where LH is on the left hand side. You're going to represent the reactants, and on the right hand side you're going to represent the products, and there will be an arrow mark in between which will point to the direction of reaction, or you can also use a word products instead of reaction. Okay, the arrow marks also point the direction of products. It will point products. Okay, so if you include these points also, then only it is going to be the perfect definition of chemical equation. I hope it is clear to you until here. So let's move on to next thing, writing the chemical equation. So generally chemical equation can be written in two ways. You can either write it as a word equation or in the form of a chemical equation. But if you have more and more reactants and products, writing word equation also will be tougher for us. Okay, so let's understand this first. So we have taken the example of burning of magnesium ribbon itself. Okay, so generally in chemistry, whenever we take burning of something, we add oxygen to it. We are going to add of oxygen to it. Okay, see, now why are we adding oxygen? We are burning it in the presence of in an atmosphere. In the atmosphere oxygen is there, so in the presence of oxygen we are burning magnesium, right? So that's why we are going to include oxygen. So we are going to write word equation for the example 1 which we have seen. Okay, so magnesium plus oxygen, this arrow mark is pointing towards the direction of product. So this is the product, these are the reactants on the LHS. Okay, now if I want to write it the chemical equation, if I have to write, I will use their symbols. So we have already learned elements till 20, but no worries, we can easily write the symbols, no need to worry about that. Okay, so magnesium is Mg, and oxygen, you will be surprised. Okay, you will be like oxygen is O and here it is written O2. Why so? See, in the atmosphere oxygen is present as O2. It is a diatomic molecule, so don't need to worry about this diatomic molecule and all that. You will be learning this in your 11th standard, not in this standard. Okay, so oxygen is a diatomic molecule. It will be bonded together in the atmosphere like this, O double bond O. So no need to learn this also, don't worry. Okay, I'm just telling for information. So the whatever oxygen we breathe also, it is O2 only, so that's why we are writing O2 here. And magnesium oxide is written as MgO. And I hope you all learned the crisscross method of writing the chemical formulae in the previous classes itself, so it will be easy for you why it is like this. Okay, so this is clear to you, I hope, word equation and chemical equation. So we'll move on to the next part, that is the type of chemical equations. So chemical equations are generally skeletal chemical equations and balanced chemical equations. Now what are these? See, when a chemical equation, when we will tell it as skeletal and when we call it as balanced, that is what we have to know. See, if the number of atoms of each elements are not same on both sides of a chemical equation, then it is a skeletal chemical equation. Now the previous one here, if you see, here magnesium is 1 and here also magnesium is 1. On the reactant side magnesium is 1, on the reactant and the product side also magnesium is 1. Here on the reactant side oxygen is 2, whereas on the product side oxygen is only 1. Here both are not the same, right? Oxygen atoms are not satisfied here. Here it is 2, here it is 1. So we can say this is a skeletal chemical equation. Okay, so that is a skeletal chemical equation. Now what is balanced chemical equation? If the number of atoms of each element are same on both sides of the chemical equation, then we can call it as balanced chemical equation. So it is very essential for us to keep the chemical equation in balanced form. So why do we need to keep it in balanced form? Why should we balance them? You will be thinking. Because if it is not balanced, it will violate the law of conservation of mass. If it is not balanced, it will violate this law. So what does this law tell? Law of conservation of mass tells that mass can neither be created nor be destroyed. Okay, very important. You have learned this in your 9th standard itself, but just recalling it. Okay, if the chemical equation is not balanced, it will violate this particular law. That is why all the chemical equations are generally balanced. So in simple words, if you ask me, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. Okay, that is the reason we will balance chemical equations. I hope this is clear to you. Next, we have to learn balancing chemical equations. So let's learn this. It's very simple. Okay. There are steps to balance the chemical equation. First step is draw boxes around each formulae and do not change anything inside the box. Okay. While balancing a chemical equation, you are supposed to write only here in this area. You are not supposed to change anything here or here. If you change that, it is going to be wrong. I hope it is clear. Okay. Very important. So we will try to balance the first equation which we have seen. Okay, that is magnesium plus oxygen gives rise to magnesium oxide. So first step is clear and we have done. The boxes are drawn already. In the second step, we need to list the number of elements. First, what are the elements present? Magnesium and oxygen, that is there. And on the LHS and RHS, how many number of atoms are present, we have to mention. And similarly for oxygen also, same thing we have done here. Okay, second step is also done. Okay, now third step, we have to see the convenience and start balancing. Okay, it is often convenient for us to start balancing with the compounds that has maximum number of atoms. So which has maximum number of atoms? That is oxygen. So oxygen has maximum number of atoms. That is why I am going to balance oxygen here. So I am going to put 2 here in order to balance oxygen. But what happened here? Because of adding 2 here, magnesium has become 2 on the RHS, whereas it is only 1 on the LHS. Now I need to balance magnesium also. So for that I have added 2 here so that it will get balanced. Now here we have 2 magnesium, 2 oxygen, 2 magnesium, 2 oxygen, both on LHS and RHS. So now we are done. We have proceeded and we have completed the step 4. Now step 5 is to check the correctness of the equation, how correct it is. So how do we check whether it is correct or not? Just count the atoms on both sides. Okay, now you have to count it correctly. Okay, and sixth step is very important step, writing the symbols of physical states. See, here I have written some small letters here, right? So these are the physical states of that particular element or compound. Okay, so here I have written S, here I have written G, here I have written S again. So I'll explain, you don't need to worry what are the physical states which you have to mention for a chemical reaction. Then it will make it correct equation. Okay, that will be correct chemical equation. So first we'll see the the physical states. Okay, symbols of physical states you have to write now. For the sixth step, all this is very much important. If the element or compound is in solid state, if it is in solid state, you have to represent in this way. You have to put a bracket and write S inside it as a subscript. You have to write it down. I have written down a subscript, it should be written. Similarly, if it is in the liquid state, then you have to write L in brackets, small l. And if it is in the gaseous state, it's represented by small g, and all these have to be written in the subscript only. Now we have another thing called as aqueous state. So what is this aqueous state? First we have to understand, because it is something new term for us, right? We'll understand this. So aqueous, when you will write this, if the reactant or product is present in the solution of water, then you will write aqueous in the subscript. Okay, so there will be some equations wherein the product or the reactant will be mixed in water. Okay, sometimes you need to mix in water, so that time you need to write aq, small aq in the subscript. That is clear, I hope. And sometimes we need to write the chemical reaction conditions, what condition is given for the particular reaction, what conditions are given, you have to mention sometimes. Okay, for example, here we have an example. CO, that is carbon monoxide plus hydrogen, gives rise to CH3OH in the presence of 340 atm. Okay, where in 340 atmospheres it will give this. Okay, not in normal conditions. So this is some reaction condition specified. It is specified above or below the arrow mark. So above the arrow mark or below arrow mark. Now this reaction is very important. Okay, you will see it in your biology also. So this is generally the photosynthesis reaction. In carbon dioxide plus water in the presence of sunlight and chlorophyll gives rise to glucose plus oxygen plus water. Okay, so here you saw aqueous, right? It will be present in water solution. Here also aqueous, that's what. Okay, here also aqueous. So this is the photosynthesis reaction, very important reaction. This is, you need to remember this. It is balanced here also, so balancing also you should remember. Okay, next is new topic, very interesting, so let's get it. Types of chemical reactions. So according to textbook, there are 5 types of chemical reaction mentioned in this particular chapter. We'll see them one after the other. It is going to be very interesting. Okay, so let's get into them. First and foremost is combination reaction. So a reaction in which single product is formed from 2 or more reactants is called as combination reaction. See, it is very simple. See, there are going to be multiple reactants, but these all are going to give a single product. That's it. Okay. See, there will be some, so A plus B gives rise to C. This is the shortcut which you can remember for combination reaction. See, here there are multiple reactants whereas the product is only one. I hope it is clear. Now let us see few examples here. First one is, this is calcium oxide, we can also call it as quicklime, plus H2O, water, gives rise to CaOH twice, that is calcium hydroxide. You can also call it as slaked lime, plus heat. See, here we have two reactants, but whereas the product is only one, that is calcium hydroxide. Okay, and it gives out heat. Okay, remember this. We'll talk about this also further in this video. Then burning of coal is also a combination reaction. See, coal is carbon plus oxygen gives rise to carbon dioxide, and formation of water from H2 and O2. That is H2 plus O2 gives rise to H2O. So these are some of the chemical reactions which comes under combination reactions. Okay, so there is something very interesting about this calcium oxide, calcium hydroxide and calcium carbonate. So I will just give you a quick brief explanation about that. See, I told you, right, CaO, that is calcium oxide, is quicklime. Just now we have seen. When we have added water to it, it becomes calcium hydroxide, that is slaked lime. And when you add carbon dioxide to this slaked lime, it becomes calcium carbonate, which is marble. Marble is calcium carbonate. Okay, so it's very it gives. See, generally a solution of calcium oxide is used for whitewashing the walls. Okay, whitewashing walls. See, what happens is they'll take quicklime, they will add water to it, so it becomes calcium hydroxide, and they will apply this calcium hydroxide on walls, and slowly it will react carbon dioxide which is present in the atmosphere. This slaked lime which is on the wall, it will react to the carbon dioxide present in the atmosphere, and it will give a very shiny appearance. Okay, a thin layer will be formed and it becomes calcium carbonate. Sometimes maybe you would have seen whitewashing walls. Okay, it is not paint but it is similar to that. Okay, yeah, that is clear, I hope. This is about calcium oxide, calcium hydroxide and calcium carbonate. So these questions also will be asked, so you need to remember this, very important. Okay, so let's move on to something called exothermic reaction. So in the first slide of combination reaction, I told you we have seen an example called calcium oxide plus water gives rise to calcium hydroxide plus heat. I told you to remember this heat, right? So why did I tell? Because I'm going to introduce a new type of reaction, that is exothermic reaction to you. Okay, so exothermic reactions are reactions in which heat is released with the formation of products. Here heat is released, that is heat is present on the product side, right? So it is released. So this is one of the exothermic reaction only. I hope it is clear. Okay, so there are few more examples on your screen. CH4, which is methane, or we can say natural gas. So when I am burning this natural gas, you will get, heat is liberated in this also. The reactants are CH4 plus oxygen, which gives rise to carbon dioxide plus water, and here lot of heat is liberated. This is an exothermic reaction. Heat is liberated. Okay, and the next one is very important, again important reaction. C6H12O6, this is glucose plus oxygen gives rise to CO2 plus H2O plus energy. So this is our respiration reaction actually, or digestion reaction. So this will also be there in biology again. Okay, see, this is glucose. Whenever you are having food, this food will get mixed with oxygen, right? We breathe oxygen, so it will get mixed with oxygen and we breathe out carbon dioxide, that is the product, and water is released and energy is also liberated. Okay, that is heat. So this is our respiration reaction. Okay, so I hope it is clear to you, exothermic reaction. So now we'll move on to next type of reaction, that is decomposition reaction. So decomposition reaction is a reaction in which there will be only single reactant. It will break down to give simpler products or more products. Okay, but reactant is one, products are more. So we can simply represent it as A gives rise to B plus C. Okay, so why I am writing in this way is, there was a question in sample paper for the 2023 batch. Okay, regarding this way, in this way only they have given question. Okay, so it will be, you will also understand, right? Yeah. Okay, so there was a question like this previous year, so that's why I'm writing for everything. Okay, so here reactant is only one, FeSO4, that is ferrous sulfate, iron sulfate. So in the presence of heat, again this heat also remember it. Okay, in the presence of heat gives rise to ferric oxide plus sulfur dioxide plus sulfur trioxide, SO3 plus SO2. So this is one of the example of decomposition reaction. Now there are types of decomposition reactions actually. There are three types of decomposition reactions. So we will see one after the another. So first one is thermal decomposition. So see, the word itself suggests, this thermal word suggests that it is carried out by heating. This decomposition is carried out by heating. That's why it is called as thermal decomposition. See, CaCO3 in the presence of heat, it will break down to CaO plus CO2. Okay, this is one of the example. Calcium, this is calcium carbonate. If you give heat, it will give you calcium oxide plus carbon dioxide. Limestone in heat, it will give quicklime. And there is one more example here we have. This is lead nitrate. In the presence of heat, it gives you lead oxide plus nitrogen dioxide plus oxygen. Okay, this is one more example of thermal decomposition. Next we have photochemical decomposition. So this is the second type of decomposition reaction. See, photochemical, photo, this suggests that this reaction is carried out in the presence of sunlight. This photo word suggests it is done in the presence of sunlight. Okay, so now if you take silver chloride, AgCl, or silver bromide, any of it, if you keep it in sunlight, it will become silver plus chloride. This gas will be going out, and here silver plus bromide. Okay, so actually silver chloride is white in color generally. In the presence of sunlight it becomes gray in color. Okay, this AgCl, so this reactions are generally used in black and white photography. Black and white photography. Okay, so that's what it's important to know this, right? Then other last one is electrochemical decomposition. Again, here the word electro suggests that this is carried out by electricity. See, now if you take a water molecule H2O, so when in the presence of electricity, what happens is you will get hydrogen and oxygen separately. Okay, you will get that. So this reaction is actually called as electrolysis of water. So electrolysis, you will learn this in the further chapters also, electrolysis. So electro means electricity and lysis means breakdown. So lysis is breakdown. So breakdown of something with in the presence of electricity is electrolysis. Okay, so here water molecule is breaking down in the presence of electricity to give hydrogen and oxygen. This is electrolysis of water. So there is an activity also based on this equation actually. Okay, so what the activity actually tells us, see, on the cathode we will be able to see that the water collected is double the amount the water connected at the anode actually. So you will see at the cathode you will collect the hydrogen gas, H2 gas will be liberated, and at the anode there will be oxygen gas which will be liberated actually in this electrolysis of water. Okay, so at the cathode you will see the double the amount of gas collected than the anode. It is because here you can see 2 moles of hydrogen is collected. That's why, see, according to the equation, if you just write it, no, you will understand why it is double. Here it is only 1 O2, whereas here it is 2 O2. That's why it will be double the amount. This question also will be there, and it is a PYQ. Okay, that's why I'm giving information. So generally hydrogen is an anion, so it is going to be collected at the cathode, and oxygen is an cation which is going to be collected at the anode. Okay, so that's why it will be double the amount. Now in all of this decomposition reaction we have seen one thing common. What is it? See, obviously only one single reactant is getting into multiple products, but we are applying some or the other energy, we are giving energy in some or the other form, right? So that is endothermic reaction. Reactions in which energy is observed along the formation of products is an endothermic reaction. In all of the cases which we have seen decomposition reactions, in all of that cases reactions are consuming energy. Okay, energy is observed, so that's why they are endothermic reaction. That's why again heat I told you to remember, right? That is why. So next we will see something interesting, displacement reaction. Okay, so this reaction is very nice. When you see, no, when you do it in the laboratory, it will be very nice. When a highly reactive element displaces a low reactive element from its aqueous solution, such a reaction is displacement reaction. See, highly reactive element and low reactive element you will learn in the further chapter, but you need to remember this very clearly. Okay, so now if you take an example, iron. If you drop a piece of iron in copper sulfate solution, so copper sulfate is an aqueous solution, right? You need to put it in water, so it is an aqueous solution. So iron plus copper sulfate will give iron sulfate plus copper. That means these two are getting displaced. That's why it is a displacement reaction. Here iron is more highly reactive than copper. That is why it is able to displace and give copper. Now if similarly if I will put copper piece in iron sulfate solution, you will see that there is no reaction. There will be no reaction. You cannot get iron plus copper sulfate. No, you will not get that, because copper is a low reactive element. Okay, that's what it is very important. That is why I'm telling you, you will learn it in the further chapters. No need to worry as of now. Okay, I hope it is clear to you. That's it about displacement reaction. When you learn that reactivity series, you can easily do this. Next is fourth type of chemical reaction, that is double displacement reaction. Reaction in which there is exchange of ions between reactants are called double displacement reaction. See, so first we'll understand with example. This is sodium sulfate, this is barium chloride. They are giving rise to barium sulfate plus sodium chloride. So generally sodium has positive charge and sulfate SO4 has negative charge. Barium chloride, see SO4 minus 2 actually. Barium has plus 2 charge and ion, and Cl2 has minus 1. See, what is going to take place is there is going to be exchange of ions. This plus 2 and this minus 2 they will get together, and this plus 1 and minus 1 they will get together. Understanding? So BaSO4 and NaCl, in that way. In this way there will be exchange. So that's it. In two ways displacement will take place. That's why it is double displacement reaction. Okay. So in this reaction actually you will see some insoluble substance, that is barium sulfate. When you do this in the laboratory, what happens is, in the test tube whatever you're taking, no, you will see some insoluble substance down and a liquid. This liquid water will be there, no, that is obviously sodium chloride mixed water. Here down you will find something insoluble substance, that is barium chloride. Okay, so now we should understand what these insoluble substances are called. Okay, and barium sulfate will be in white color. I'm telling that, it is important only. So that insoluble substance, we will call it as precipitate in chemical terms, and a reaction which will that produces precipitate is called as a precipitation reaction. So this reaction is not only double displacement reaction, it is a precipitation reaction, because we are getting a white precipitate. So white, you can write precipitate as PPT. Okay, not PowerPoint presentation, PPT is precipitate. Okay, so that is about the precipitation reaction. Next is the fifth type of reaction is redox reaction. But before moving on to redox reaction, we shall see two more reactions, that is oxidation reaction and reduction reaction. So what is oxidation reaction? Whenever in a reaction, if you see gain of oxygen or loss of hydrogen, you can say that that reaction is oxidation reaction. So not only gain of oxygen but loss of hydrogen is also oxidation reaction. Okay. So now I am giving an example of burning of copper. See, copper Cu plus O2 gives rise to Cu, copper oxide, in the presence of heat. That's what burning. So it is clear, right? Copper is getting oxidized. Next we will see reduction reaction. Just ulta. Gain of hydrogen or loss of oxygen is called as reduction reaction. See, in the previous reaction what we have done is copper plus oxygen gives rise to copper oxide. Now if I want to get back copper from copper oxide, I can simply add hydrogen and I'll get copper plus water. Okay, I'm getting my reactant back, right? So here we can see gain of loss of oxygen is very clear for copper oxide. That's why it is a reduction reaction. Okay, I'll tell you more about this reaction. Remember this. Okay, yeah. Now we'll move on to redox reaction. See, redox, this word, first we'll see this word and understand this word. See, read, R-E-D, red is nothing but reduction. Okay, and ox, this expresses oxidation. So the reaction in which one reactant gets oxidized and the other reactant gets reduced, then we will say that as a redox reaction or oxidation reduction reaction. That's why first I told you other two and then a redox reaction. See, the same equation is here on your screen. See, CuO plus H2 gives rise to Cu plus H2O. See, here CuO, that is copper oxide, is losing oxygen, so it is a reduction. And H2O is obtaining that lost oxygen, so it is oxidation. You will see both reduction and oxidation in this particular reaction, so it is a redox reaction. So with this we have completed the chapter. Thanks for watching our video. Do like, share and subscribe to Vishwablooms. Don't forget to click the bell icon. Bye bye.